Hello and welcome to Edusaathi's lecture on permutations and combinations. This is a slightly confusing and a difficult topic, but in this lecture, we'll go step by step so that you clear all your fundamentals here. Make sure you don't skip this topic because it is asked a lot of times in all competitive examinations. So let's begin.
This is gonna be the broad outline of what I'll be covering in this particular video lecture. We'll have the factorial first, then we'll have the basic principle of counting. This is actually the base of permutations and combinations, and if you're clear with this, I think you can get every question correct. Then we'll move on to what is a permutation, then what is a combination, then we'll move on to the relation between permutations and combinations. Then we'll move on to identical things, like how do you permute or how do you combine different things when you have two or more of the same kind. We'll move on, then we'll have circular permutations, arrangements around a polygon, and finally we'll end with groupings. So we'll start with factorial. So what is a factorial? The factorial of a natural number, keep in mind factorial is only defined for a natural number, is defined as a product of all consecutive natural numbers from 1 to that particular number. For example, let's take 5 factorial. Now what would be 5 factorial? Sorry for that. What would be 5 factorial? 5 factorial would be 5 into 4 into 3 into 2 into 1. So what do I do is I have the product of all consecutive natural numbers from 1. So from 1 to that particular number. To which number? To 5. So this gives me 120, 120. So 5 factorial is 120. Similarly, if I have 6 factorial, I'll multiply this by 6 from 1 till 6 and so on. Let's take another example. So what if we are asked what is 17 factorial divided by 12 factorial? So what is 17 factorial? I'll start from 17 and I'll multiply all the natural numbers till I reach the smallest natural number, which is 1. So I have 17 into 16 into 15 into 14 into 13 into 12 into 11 and so on till 1. Now I have to divide this. I have to divide this entire thing by 12 factorial. So 12 factorial is what? 12 into 11 into 10 and so on till 1. So now what you notice here is that this actually is 12 factorial, because I start from 12 and I go till 1, and here also this is 12 factorial. So when you divide, this thing will cancel out. So what is the answer here? 17 into 16 into 15 into 14 into 13. So this is my final answer for 17 factorial by 12 factorial. Okay, so one thing you need to note here is 0 factorial is 1. So whenever you have 0 factorial in the question, you write it as 1. Keep in mind that division by 0 is not possible. For example, if I write 12 divided by 0, this is not defined because we cannot divide by 0. But if I write 12 divided by 0 factorial, this is 1. So 12 divided by 0 factorial is actually 12, which is nothing but 12 by 1. So 0 factorial is 1. Okay, so this is the first thing we discussed in permutation and combination. I hope everything is clear. We discussed what is a factorial. Let's move on to the second topic, which is basic principle of counting. Now we have actually two principles here, so I'll discuss both of the principles one by one. The first principle is the product rule, or we call it the rule of AND. Why do we call it the product rule or the rule of AND? I'll tell you later. So let's take an example here. Let's assume that I am in the city Lyon. I am here. For those who don't know, Lyon is a city in France, Geneva is another city in Switzerland, and Zurich again is in Switzerland. So let's assume that I am here and in Lyon and I want to go to Zurich. There is no way I can go from Lyon to Zurich directly. I have to go through Geneva. Okay, because this city, Geneva, actually lands in the middle of Lyon and Zurich if you check the maps also. So for example, let's assume that I have 3 ways of going from Lyon to Geneva. Let's label this way as A, this as B, and the third way as C. Just a minute, I'll just change the ink color so that it's more clear. Now I have 3 ways to go from Lyon to Geneva, and let's assume that I have 4 ways of going from Geneva to Zurich. So I have 4 ways. I have this first way, this is the second way, this is the third way, and this is the fourth way. So again, I am here in Lyon and I want to go to Zurich. I have to pass through Geneva. 3 ways of going from Lyon to Geneva and 4 ways of going from Geneva to Zurich. So the question is, in how many ways can I go from Lyon to Zurich? I have to find out the number of ways. So the answer here is 3 ways from Lyon to Geneva multiplied by 4 ways from Geneva to Zurich. So I'll have a total of 12 ways. What are those 12 ways? Let's list down. What are the different possibilities? I can go from Lyon to Geneva either through route A, and then I can go from Geneva to Zurich through the first route here, 1. So one route is A1. Or I can take the same route here A, but here I can take the route number 2. So I'll have A2. Or I can take A here and the third route here. Or I can go through A3 and similarly A4. Also, I can take the second route from Lyon to Geneva, which is B, and then take the route number 1. So I'll have here, what is this? B1. Similarly, I will have B2, B3 and B4. If I take the third route from Lyon to Geneva, I'll have C1, C2, C3 and C4. So in all, if you calculate, we will have these 12 possibilities as we pointed out earlier. So in all, we have these 12 ways. So why do we call it the rule of AND? Because whenever you solve these kind of questions, you'll always speak in your mind. Okay, so what will you say? I want to go from Lyon to Geneva and from Geneva to Zurich. So whenever you have this word AND in your mind, or whenever you speak the question in your heart, always remember that you will use a multiplication sign. So here I want to go from Lyon to Geneva and from Geneva to Zurich. So I will multiply the number of ways from Lyon to Geneva, which are 3, and the number of ways from Geneva to Zurich, which are 4. So the total number of ways I have here is 12 ways. Okay, so this is the first basic principle of counting, which is the product rule. Let's move on to the second principle of counting, which is the addition rule. We had the product rule, here we have the addition rule. We use the plus sign or the rule of OR. Let's again take the same example. We are here, we have 3 cities, Lyon, Geneva and Zurich. Now let's suppose that in this case I am here at Geneva. I am here, but for some reason I don't like the city. I would either want to shift to Lyon, or I would want to shift to Zurich. Okay, so now remember that I've said or. Either I'll move to Lyon or I'll move to Zurich because I don't like Geneva for any reason. Now let's assume the same case. I had three ways of going from Lyon to Geneva. The three ways are A, B, and C, and I had four ways connecting Geneva and Zurich. So all these roads are two-way roads. Don't think that I can go only from Geneva to Zurich using these four roads. I can also come back. Okay, so these are two-way routes or roads, whatever you want to consider. So I am here in Geneva and I want to go either to Lyon or to Zurich. Now in how many ways can I do this? How many ways can I escape this city which I don't like? So the first option is that I go to Lyon. I can go to Lyon in how many ways? Three ways. Or I can go to Zurich following how many ways? Four ways. So here instead of the multiplication sign, we use the addition sign. 3 plus 4, which is 7. Now get your fundamentals clear here itself so that you don't face a problem when we move to the rest of the slides. So I could move from Geneva to Lyon using these three paths. So I start from here and I end up here. I can do this only three ways. Or I can go from Geneva to Zurich following this four ways using four ways. There is no and. Either I will come to this city or I will go to Zurich. So that is why we use this plus sign. So we will have 7 ways. And what are the ways here? Sorry for that. What are the ways here? The three ways are either I take A, or I take B, or I take C. The three ways to go to Lyon. Or the four ways, I take either the route number 1, or the second route, or the third route, or the fourth route. These are the ways I can exit to Zurich. So the total number of ways is 7 ways. Okay, so why do we call it the rule of or? Because I was here in Geneva and I could go either to Lyon or to Zurich. So I use the word or. So whenever while solving a question in your mind or reading a question in your mind, you have this word or figuring out somewhere, always remember you'll use plus, the plus sign. So here either Lyon or Zurich. So I have 3 plus 4, which is equal to 7. I hope you've understood some amount of these principles. We'll do some more applications right now so that you have a better clarity on what is the addition rule or the product rule. Let's take some examples now. So we have the first practice questions. What are the total number of 3-digit numbers? So how do you calculate 3-digit numbers? Now 3-digit numbers, let's draw 3 spaces here. I have 3 spaces because a 3-digit number will have some letter on the numeric, some number on the hundredths place, some number on the tenths place, and some number on the units place. So this is the hundredths place, this is the tenths place, and this is the units place. Okay, so this is basic mathematics we did in class 4 or 5. So 3-digit numbers here. So now let's think it with the perspective of the product rule and the or rule. To form a 3-digit number, I need a number here, and I need a number here, and I need a number here. So the first thing is that I will apply the rule of and I will have to multiply whatever the number of ways exist. So let's start with the units place. In how many ways can we fill up the units place? The units place can either be 0 or be 1 or 2 or 3 or we can have 4 or 5 or 6 or 7 or 8 or 9. So we only have these 10 digits which can figure up in the units place. So the units place can be filled up in 10 ways. Similarly, the 10th place, the tens place as we call it, can also be filled up in 10 ways. So we have 10 here and 10 here. Now you need to give it a thought that in how many ways can we fill up this hundreds place. Now this is where most of the students will fall into the trap and mark the wrong answer. Now if you see carefully, in this hundreds place I cannot write 0. This 0 cannot figure out here, because if I write 0 in the hundreds place and I write any number on the tenths place and the units place, I will have a 2-digit number. 023 is a number 23. 045 is a number just 45. So in the hundreds place I can never have 0. Rest all of the digits I can have 1, I can have 2, I can have 3, I can have 4, I can have 5, 6, 7, 8 or 9. So the hundreds place can be filled up in only 9 ways. So what are the total number of 3-digit numbers that we need? Let me draw a figure here again. We had 3 spaces. This units place can be filled up in 10 ways. This can be filled up in 10 ways, and this also can be filled up in 9 ways. So because we need a number here and a number here and a number here, I will, because we are using this AND symbol, I will multiply here and not add. So the total number of 3-digit numbers are 9 into 10 into 10, which are how many? 900 numbers. I will have 900 numbers which are of 3 digits. Now all these numbers are covered up in this 900 numbers. Any number you can think of, any 3-digit number. Also, if you go by basic calculation we did in class 4 or 5, the highest 3-digit number is what? 999, and the smallest is what? 100, and we add 1 because both of them are inclusive, and this gives you 900 minus 100 is 899 plus 1, which is 900. So the answer we found here, 900, is actually correct. Okay, I hope this is clear, and let's move on to the next practice question. So let's move on to this second question on the principle of counting. What are the total number of 3-digit numbers in case no repetition of digits is allowed? So if you note here carefully, the previous question we did where we found out that the total number of 3-digit numbers are 900 includes the numbers such as, let's say, 333, or a number such as 2, 4 and 2, or a number such as 8, 4 and 4. So basically these 900 numbers include the numbers where a digit is repeated more than once. For example, here we have 3 threes, so the 3 turns up 3 times. Here we have 2 coming up twice. Here we have 4 coming up twice. This question asks me that I need to find out the total number of 3-digit numbers such that none of these digits is repeated. So all these digits should not figure out in this particular question. So I can have a number like 3, 4, 5 or 6, 8 and 9 where every digit is distinct. So let's see how to solve this kind of a question. Again, since there is a 3-digit number, I will draw here 3 spaces. This is the units place as discussed earlier. This is the tenths place, and this is the hundreds place. Let's start from the hundreds place. In how many ways can we fill up this hundreds place? As I told you before, I cannot have 0 here, because if 0 turns up, this number ends up being a 2-digit number. So rest all of the digits any one of them, 1 2 3 4 5 6 7 8 or 9, can figure out in this hundreds place. So for this hundreds place I have 9 ways. Except 0, any of these digits can turn up in this hundreds place. In the tenths place, now imagine that out of these 9 digits, one number, any one number, let's take 5, has already been used in the hundredth place. So now 5 cannot occur again because we are given that no repetition is allowed. So for the tens place, I will have the digits as 0, 1, 2, 3, 4. 5 cannot occur again. 6, 7, 8 and 9. Now take notice that 0 can come in the 10th place. I've already discussed this in the previous question. So again, for this tens place, I have how many digits? 9 digits, because 0 is included from this set and 5 has been deleted. So again, the tens place can be filled up in how many ways? 9 ways. Now we've already utilized 2 of the digits. One was filled, let's say 5 was filled in the hundreds place, and one of them has been filled up in the tens place. So we are left now, let's take 5 was here and the 10th place was filled up with 2. You can take any number. I'm just taking an example that let's say 2 was filled up. So now I'm left with 8 digits for the units place. So the units place can be filled up in 8 ways. Okay, so the answer to this question would be, since this is the product rule and an AND case, because I need the first number and I need the second number and I need the third number, so the answer is 9 multiplied by 9 and multiplied by 8, which gives me 648 numbers. So this is the answer to the question that if we want to find out the number of 3-digit numbers in case no repetition is allowed. I hope this is clear. Let's move on to another application for basic principle of counting. Consider this question. In a class, a teacher wants to select a monitor among 30 boys and 32 girls. In how many ways can he do so? Now, the teacher can select a monitor and the monitor can either be a boy or a girl. This is a simple question, right? Because the total number of students is 30 plus 2, 30 plus 32, which is 62. So I will have 62 ways of selecting a monitor, because I can choose anyone as a monitor. So the basic reason for this question is I can choose a boy or a girl. Wherever or comes, I use this plus sign and I have 30 plus 32, which is 62 ways. Now let's tweak this question a little. That gives us the next question. In a class, a teacher wants to select 2 monitors now. We had a single monitor in the previous case. Now I want 2 monitors here among 30 boys and 32 girls. In how many ways can he do so if one has to be a boy and the other one has to be a girl? So here I want to select one boy, and remember this and one girl. So in how many ways can I select a boy? I have total of 30 boys. So number of ways of selecting one boy is 30 ways. And since I'm using and, so we'll use the product rule here. So I'll have this multiplication sign and one girl. In how many ways can I choose a girl? Since I have 32 girls, I can choose a girl in 32 ways. So what is the answer? The answer is 960. So I can have 960 pairs that can be found if I need a boy and a girl. I hope that's clear. Now what if the question said that I want to select just 2 monitors and this condition of a boy and a girl is waived off? Let's suppose that this condition does not exist. I just want to select 2 monitors and there is no other condition. Then in how many ways can I do this? I have total number of students 30 plus 32, which is 62. So for the first place, I can select a monitor in how many ways? 62 ways. Then for the second monitor, now one monitor has already been chosen out of these 62. My monitor has already been chosen. Sorry for the bad 6. So how many students are left for the left who can apply for the second position of monitor? 61. So what is the answer in this case? The answer would be 62 multiplied by 61. This is the answer if I have to select two monitors and there is no condition that one has to be a boy and the other one has to be a girl. So the questions might vary, but if you're clear with the fundamentals, I don't think you'll find any difficulty in solving this. So this gives me 3782 ways. If you multiply this is 3782 ways. So you can see there's a considerable difference in the answer. So one condition wavered off increases the number of ways I can choose, because in this case I can have two boys, two girls, one boy and one girl. Any combination will do. So let's move on to the next question. So read this question carefully. There are 4 multiple choice questions in an examination. The first 2 have 3 choices each, whereas the last 2 have 5 choices each. If all the questions need to be answered, then what is the number of permutations that are possible? Let's try solving this. So I have 4 multiple choice questions. I label them as 1, 2, 3 and 4. So for the first question, how many options do I have? I have 3 choices, 3 answer choices. So I make 3 dash. For the second one also, I have 3 answer choices. So I make another 3 dashes here. For the last 2, I have 5 answer options each. For the third one and the fourth one. These answer options are nothing but like we have A, B, C and A, B, C, and here we have 2 extra options. So now I need to answer all these questions. This is the condition. So how many different sequences are possible? Let's figure out. For the first question, I need to answer from one of these 3 options. So the number of ways of answering the first question is 3 ways. The number of ways of answering the second question is also 3 ways. Here we will have 5 ways, and again here I have 5 ways, because I can choose any one of the answer options A, B, C, D or E. So what are the total number of ways? Now here a lot of people get confused. What they end up doing is they end up adding these numbers, which is not true. Why it is not true? Because here it is given that all the questions need to be answered. It means that I have to answer the first question, and I have to answer the second question, and I have to answer the third question, and I have to answer the fourth question. So I am using and here, means all the questions need to be answered. So what would be the answer here? Wherever we have and, we use the multiplication sign. So I have 3 into 3 into 5 into 5. So these are the total number of ways in which, total number of sequences which are possible for this particular question. So I have 25 into 9, which is 225 ways. So don't get confused and add these. We have to multiply because the condition is we need to answer all the questions. So I have and